Hello everyone, my name is Queen Lam Ha and I would like to share with you chapter 8 from Pearson, third edition. I will look through the PowerPoint with you, the PowerPoint on 8.1 and 8.2. 8.3 and 8.4 I will give you another lecture later in the same chapters. And right now I would like to share 8.1 right now. So for section 8.1, you will learn about hypothesis testing for population proportion. And what is it? We will go deeper inside each section of chapter 8. So I would like you to go into details on section 8.1. 8.1, we're talking about the essential ingredients of hypothesis testings. So what do we need? What do we care? So for here, you can see you need to know how to write null hypothesis and alternative hypothesis for a test involving a population proportion. So population proportion here, we're talking about P, okay? So you are testing for P. So, and then you would learn how to compute and interpret a test, statistics, and P-value. So P-value right here talking about the probability under the curve. And this probability might be on the right, might be on the left, or might be both. And they have another name for the P-value is probabilities. You will learn how to compute this by compute by t-test or z-test. But for this population proportion, you will do z-test only. And you need to interpret that test by drawing a conclusion, and then you can interpret, do you accept the null hypothesis or you reject the null hypothesis. So we will do some process and you will do step by step, so no worries. So for this slide, hypothesis testing, what does it mean? Hypothesis testing is just a procedure that enables us to choose between two claims when we have variability in our measurements. So these two claims, they're talking about null hypothesis and alternative hypothesis. So the example and more explanation are right here. So in general, this hypothesis testing, you have 4 steps. Step 1, hypothesize. So these steps, you need to state the hypothesis or your claim. The claim from the question or in the middle of the story. So that will be weighed against a neutral, skeptical claim. So you will understand this. If I jump to a later example, then I will analyze this for you. So to state the hypothesis or the claim, so you will need to know where is your H0, which is null hypothesis, and where is your HA, which is alternative hypothesis. And then next, you will prepare. You need to determine how you will use the data to make your decisions and make sure you have enough data to minimize the probability of making mistakes. Step 3, we will compute to compare. To compute for this step, you need to collect data and compare them to your expectation. So for this step, usually people looking for Z value or Z score, and then from there, you will know how to compute P value. Step 4, interpret. You need to state your conclusion. You need to state your conclusion based on your p-value, which is you just compute in step 3. And you're asking yourself, do you believe the claim, or do you find that the claim doesn't have enough evidence to back it up? So this is talking about if your p-value compared to alpha, alpha in this case will be level of significance. So alpha, later they will have notation for you to look at. What does it mean, level of significance? So you will compute p-value compared to alpha, which is level of significance. If its p-value is smaller than alpha, you need to reject the claim. Or the opposite. If your p-value greater or equal to alpha, you do not reject the claim. Here is in the introductory example about hypothesis testing. A coin is spun on a flat surface. So you hypothesize it is more likely to come up ahead. Because that side is a coin bulges out slightly compared to the tail size. You spin the coin 20 times and it's come up heads all 20 times. If it was equally likely that the coin stops on heads or tails after spinning, it would be very unusual to find 20 heads in 20 spin of a coin. And I don't think it's ever happened. So this is so unusual that you would conclude that your hypothesis that the coin is more likely to come up heads when spinning is correct. So here the story telling you kind of overall overview, talking about how you can see the claim. So the claim right here look like they're talking about 20 heads on 20 in 20 spin of the coin, right? But some people believe it, some people do not believe it. So that is the alternative hypothesis. So right here is the explanation. First step, you stated the hypothesis that the coin is more likely to come up heads, and test this against the neutral hypothesis that the coin is fair. Step 2, you decided that you would use the proportion of heads in 20 spin of the coin to test your hypothesis. Step 3, you collected data, so 20 spins resulted in 20 heads, and compare them to your expectation. If the coin was not more likely to land on heads, you would expect about 50% of the spins, or about 10 spins out of 20 spins, to result in heads. However, you got the result of 20 heads, which is much greater than you expected. Step 4, because it could be shown likely to get 20 heads in 20 spins, if the coin was equally likely to land on heads or tails when spun. You conclude that the coin is more likely to land on heads when spun. So this example actually don't compute or don't tell you anything because it doesn't have enough data. So this story just talking about you are toss a coin, you flip a coin 20 times, and what do you expect to get? And you compare with what you doubt. So here is just an introductory example. This won't be on your test. However, the more complicated example will come later, and you will see what I'm talking about. You must to involving computation, involving interpretation, and how to compute z-value and so on. You need to know more information. You need to know alpha in the story. You need to know what is the sample. You need to know what is the population, what is the population proportion, what is the z-value. You compute the z-value, and is it the right tail test or left tail test or two tail test? I'm talking about the p-value on the left side or the right side on both. So here is the slide telling you specific, more kind of understand deeper about null hypothesis. What is the notation of null hypothesis and what notation for alternative hypothesis and so on. So again, don't panic. So you need to do slow. So this 8.1 look like they introduce you the notations. How does it look like? The story might be look like this. You will interpret like that. Will become. You will follow 4 steps or 5 steps that they given. So here, just kind of understand how to notate null hypothesis, alternate hypothesis, level of significance, and the side, is it the left tail, right tail, or 2 tails? And is it z value? Does it have enough information? Does it have p hat, q hat, sample size, and so on? And again, there will be more specific example will be on your test, might be on 8.1, on 8.2, and 8.3, and 8.4. Okay. So on this slide, they introduce us H naught right here. As you can see, we call this the null hypothesis. So this is actually the neutral. So the neutral is in the story all the time remain like this percentage. Because for null hypothesis, for this hypothesis testing, you are testing about population proportion. So mostly you are testing for the number for null hypothesis will be a fraction or percent. So here they said the null hypothesis tends to be neutral, status quo, and skeptical statement about the population parameters. And this null hypothesis all the time will contain equal sign, which means when you are state null hypothesis from the story, from the question, you will write H naught equal to a fraction or percent or a number or decimal number. So mostly because, like I told you again, this is all talking about population proportion. So the number for null hypothesis, you will convert into decimal from percent, or you keep the percent, or you can write in fractions, okay? So 3 forms you can see. For the alternative hypothesis, which is HA, H subscript A. So this will be all the time will be the research hypothesis. So this usually we are like doubting, right? Or you got question on this. Is it greater? There's some keywords for you to identify. Is it this alternate hypothesis they are talking about greater than psi or less than psi or not equal to psi? So you will see the hint. And again, I will show you the hint in the actual example. But for some famous keywords in the alternate hypothesis, identify the left or the right or both sides will be the word such as the word longer. Longer represent for greater than, shorter represent for less than, or different represent for not equal to, and stuff like that. So you will see more. And the alternate hypothesis actually is the statement about a population parameter we intend to demonstrate is true. And always contain HA less than a number, decimal number, fraction, or percent. Or case 2 could be HA greater than fraction, percent, or a decimal number. Case 3 will be HA not equal to a fraction, or percent, or a decimal number. It's based on the story. Then the number will be H naught from H naught and HA will be, you will see it. Note that the hypotheses are always about population parameters. They are never about sample statistics. So you're testing this, you're testing for the population. You're not testing for a sample. The null hypothesis. So let's go deeper about the null hypothesis. The null hypothesis always get the benefit of the doubt throughout the hypothesis testing procedure. We only reject the null hypothesis if the observed outcome is extremely unusual, if the null hypothesis were true. So in other words, it is analogous to assume that a defendant in a jury trial is innocent unless proven guilty beyond a reasonable doubt. Actually, this one, you don't need to worry about the second sentences right here from the second paragraph right there. So for the null hypothesis, so all the time will be, so when you are writing your hypothesis test, you write H naught equal to a value from your prompt. But here they explain a bit more for you to understand the null hypothesis. Is you don't have to write this whole thing on your test or on your work. Example for this one. They're talking about global warming. So 2014, Pew poll found that 68% of Americans believe in global warming. The researcher believes this rate has declined, going down, right? So state the null and alternative hypothesis in words and in symbols. So this one, they didn't actually tell you to write the whole complete hypothesis testing, but right here, they just expect you to practice how to write null hypothesis, which is H naught, and how to write HA in word or in symbol. So right here, as you can see, the null hypothesis will be the first sentence, and the alternate hypothesis will be the second sentence from a researcher believe this grade has declined. So this, you will write H naught will be equal to 61%. Or you can write H naught equal to 0.61, right? Or some people like fraction, they can write H naught equal to 61 over 100. But to me, I prefer decimal number. You will write H naught equal to 0.61. The reason is I do not want you to get confusing with percent. So for alternate hypothesis, you will write right here, the keywords right here for you. You can see the word has declined. It means it's less than notation. So you will write HA less than 0.61, okay? So you run. Right here, they give you the solution. They write H naught and 2 dots right here, the column right there. P represent for proportion. So you write P equal to 0.61. That convert into decimal. So remember, you are testing population proportion. So don't forget to include P, small p right there. So H naught, colon, P equal 0.61. And HA, colon, P less than 0.61. So on your test, you don't have to write in word just for you to know by yourself. But on your test, you only need to write H naught and then HA and then write the whole data out, okay? So for this case, that example is done. So for this slide, they're talking about one-sided versus two-sided hypothesis. What does it mean? It means, you notice here, they have 3 columns. The first column, they're talking about two-sided. Two-sided is mean they're talking about two tail tests. They will use for the alternate hypothesis will be P not equal to P naught. Actually, P naught is the value that from the claim. For example, the previous example, you are talking about 61%. So P naught will be 61% in this case. And remember to write null hypothesis first. Null hypothesis H naught colon P equal to P naught, which is 61% replaced right here. And if the alternate hypothesis, they're talking about something like not equal to, or they are known about here, so you write not equal to P naught. And if they're talking about case 2, maybe case 2, they talk about one-sided, but the left side. If the left side, you notice all the null hypothesis keep the same, but the alternate hypothesis will be different. So for the left case, which is the case that previous example they're talking about has decline, right? So then this would be HA colon P less than P naught. And people can replace previous example, you can take would be 0.61 in this case. And case 3, if previous example they're talking about increasing, so you will write HA colon P greater than P naught, or you can replace P naught at 0.61 in this case. They're talking about the right side, the right tail. And this is the left side, the left area tail. And this will be the not equal to. So I can annotate for you right here to look at the case when you are graph for the next step. So that's this case. The case 1, so usually when you find the probability or p-value, you graph this because you this p-value you need to compute z, so you should look at the z table, or you look at you can run StatQuant, they can compute it for you right away. So here they're talking about two-sided. It's mean they're talking about this side and this side combine to form the p-value. So it means for p-value for this case two-sided, you have to add this left area plus the right area right here. And how do you compute this? You can go back to chapter 6 to review how you find this. Okay, you got 2 ways. The first way you can run by StatQuant. Second way you can compute by using calculators or by hands. Case 2, the p-value will be this, the left side, right? So I will draw the left side. Sorry, it's not pretty. So this your p-value will be right here. So if your p-value is greater than the level of the significance, which is alpha, so alpha like this represent for level of significance. All the time that we're setting up like 1%, 5%, then we will compare the p-value that we compute in step 3 to compare back to this alpha. If p-value is smaller than this, we will reject the null hypothesis and the opposite. And the case 3, they're talking about the right tail. So you will graph the right area. Okay, so you find p-value right here. This is your p-value. Sorry, cut apart. I'm sorry, my mouse is like crazy. Actually, this is p-value. I know I'm not using pen. I'm using my finger now. Oh my God. No, it's not works. Usually I have my pen with me, but today I don't. Anyway, p-value. Okay, there you go. Okay. Okay, example 2 is a bit require us to do more steps. And I will erase this so that you can see better on the second example. Okay, second example 2, talking about internet sales. So during the previous fiscal year, 30% of retailers' sales were due to online sales. So you remember the data 30% right here. Okay, keep that in mind and keep reading. In an effort to increase, you see the word, see some keywords in here? In an effort to increase this percentage, the retailer has purchased ads on social media sites. So the retailer has purchased ads on social media site. I think they repeat twice, right? Okay. The retailer gathers data on types of sales on a sample of 20 days during the current fiscal year. So has there been a change in online sales? So right here you see two data and some keywords. So you got 30% of the retailer sales, that regular fiscal years, they sell 30% due to online sales. Were due to online sales, yes. And some keywords right here that I see the word increase this percentage, so they purchase ad on social media, right? And so I have the keywords increase in my mind as I might thinking about that's the right tail area. So I will provide p-value on my right side. And I keep reading and I keep in my mind, okay, the retailer gather type of sale about a sample of 20 days. So that is your N, right? Sample size, 20 days. So that I can point out, I forgot to tell you 30% here. What do you think? This will be P naught, right? So now keep reading. So has there been a change in online sales? So in order to answer this question, you have to compute first and then write a conclusion. So you need to interpret that. So the first step, you need to write H naught and HA for the retailer. So H naught will be equal to 30% or 0.3, right? And HA will be the word increase. They're talking about the right tail, which means HA colon P greater than 0.3. And I repeat one more time, H naught colon P equal 0.3, right? So write in decimal form is better. And step 2, they're asking, is there, question 2, they're asking, is there one-sided or two-sided hypothesis? So there's no keywords talking about two-sided. So here just one-sided, and I interpret by using the word increase that I saw in the prompts right here. It's telling me it's one-sided and it's on the right side. So what other hypothesis could the retailer have posed? And in order to answer all of this in detail, I underline all the keywords, setting up all of that. And right here, even though they don't say step 1, step 2, but this is, let's go deeper. How does interpret this? So for case 1, so they said here, H naught colon P equal 0.3, you can write 0.30 or 0.3. HA will be P not equal to 0.3, but don't think you have to interpret all of this case and then choose the correct one. So here they show you all options, right? So the first case, they say, okay, this is two-sided hypothesis. What do you think? Is it anything talking about two-sided? Any keywords for it? And so they give you the hint right here. The retailer could also have asked, have sales increased if they the retailer could also have asked, have the sales increase, then you are having null hypothesis equal to P equal to 0.3, and alternate hypothesis would be P greater than 0.3. This would be a one-sided test to the right side. And if they're asking, have sales decreased, then the hypothesis will be one-sided, but the left tail, right? So the keywords here for you to be telling us is decrease. So you got H naught colon P equal to 0.3, HA P less than 0.3, and this would be one side left test. So here they give us three options. But for us, you have to pick the correct one, depend on the wording that they give hint to us. And significance level. The significant level is the probability of making mistakes, of rejecting the null hypothesis when, in fact, the null hypothesis is true. So this level of significance, I just tell you, they notate as alpha. This is how they notate alpha, okay? Another word, they notate like this. If you write in, let's see, like this, okay? For most applications of the significant level of 0.05, or another word is 5%, and they can use 0.01, which is 1%, or they can also use 10% or 0.1. Usually, most of the problem they're using 1% or 5%. They want to eliminate the mistakes of rejecting. So they like to use 1% or 5%. And this is test statistic, which is step 3 in hypothesis testing. So for test statistics, for this one, they will, let me see, what do they analyze for this one? So the test statistic compare our observed outcome with the outcome we would get if the null hypothesis is true. Again, I repeat that. And for the test statistic, all the time they will apply z-value. So that will have the formula for you. The z-value is not like the z-value that you learn in chapter 6. In chapter 6, you learn z-value equal to x minus x bar divided by n, right? But for or z equal to x x minus mu divided by sigma, stuff like that. I set the wrong formula in at first will be z equal to x minus x bar divided by s, not n. I'm sorry. Because there are many formula for z value. Another z value that I remember will relate to n is they're using the square root, but I don't want to mention that right now. That relates to the central limit theorem. But for this case, for the population proportion, you will learn the z value will be I think the square root of p times q. Q actually is the opposite meaning with p. But you, again, I don't want to say it wrong, but I might forget it, but As later they will have the formula for us, so I don't want to read you the wrong directions. Right here, I would like to continue talking about the test statistic. They said when the test statistic is far away from the value, we would expect that if the null hypothesis is true, and we reject the null hypothesis and conclude the evidence support the alternate hypothesis. So right here, when you're testing with a z value, you have the value, so that z value will help you to find p value, and from p value then you can interpret more of this. Okay, yeah, I'm glad that I see it here. The z value that I have saw at the bottom right here. The test statistics has the structure below. Z equal to the observed value. Okay, the observed value actually is P naught, okay, minus, the null value is P naught. Okay, the null value is P naught, which is from the prompt. And the observed value is what they observe, what they collect, what the researcher collect, what researchers see, then those will be the observed value, observed data. So you would take that data, you minus the P naught, which is from the prompt, which is the percentage already given before. And SE is another word, is the standard deviation or standard error. So the standard error for the population proportion case, which is right here, the word, they're talking about P and P hat right here. So you will using the formula below. So we have the test statistics of Z. This will be the value that you need to compute before you can find P value. So you got Z equal to P hat. So P hat will be the observed value. P hat will be all the time, will be fraction or percent already given from the observed, from the researcher. P hat minus P naught. So P naught is the value all the time staying in the prompt, okay? And divided by SE. SE you have to compute another step. So we have SE equal to the square root of P naught, okay, time 1 minus P naught, and then close that parenthesis. Everything divided by N. When you've done that, and then you do the square root of those values inside, then you replace that SE back into the Z form, and then you compute a calculator, and you got the value for Z. Z value can be negative, can be 0, and can be positive. And Z value also can be a decimal number. Remember that, okay? So depend on is the left or the right tail. You must look at the table that I posted on Canvas, saying Z value or T value. Then you can look at there, or you can run by StatCrunch. So if you run by StatCrunch, it's go out right away. You just enter the observed value and no value, and SE, you got a solution. You don't have to worry about how to look at the table, okay? So right here, P hat is a sample proportion. This will be from the observed data. P naught is the proportion found in your null hypothesis. And here is the example. So this actually, let me see if it's so for this example, they want you to do step 1 and step 2. Okay, so step 2 and step 3. Okay, let's read this together. So in 2001, the Gallup poll reported that 12% of Americans were cool skeptics who reported worrying a little or not at all about global warming. So for this, in this sentence, you notice the data is 12%. In your mind, Is it P naught or P hat? So you have to thinking about that one. And you keep reading it. So I will show you the hint how to identify P naught or P hat. Okay, so in 2014, so now reading the second sentence, 25% of those responding to the Gallup poll classified themselves as cool skeptics. So the second sentence is look like, is it observed data to you? Yes. Yeah, is 25% will be the observed data. So now you can identify, you can go back to 12%. So you got P hat 25%. Your P naught will be 12%. So keep reading sentence number 3. Assume that the sample size of size for 2004 poll was 500. So this is your N, right? So N would be 500. N will be 500. So you write it down. The question is, can we conclude that the percentage of Americans who identify themselves as cool skeptics has increased? So this is another word, has increased, which is talking about the greater than, which is one tail but the right side since 2001. So you look at this. So I conclude one more time. So to me, I interpret this whole thing, whole problem right here. I identify my null hypothesis will be H naught colon P equal to 12% or 0.12. Hypothesis will be HA colon P greater than, right? Greater than 0.12. And in my mind, I still have P hat. P hat is 25%, which is the observed data, 25% or 0.25. And my N is 500. So how about previous formula? You need to know what? You need to know P hat, P naught, and SE. We didn't know SE. However, to compute SE, you have to compute separate. You have to take the square root of P naught in here will be what? For that case will be 0.12 times 1 minus 0.12 will be 0.88, right? And divided by 500. You have SE. You got SE. If you use that crunch, you plug everything in. Hopefully later I will run it for you to see it. So keep this in mind. They're talking about the right tail, right? Increase. And you will see it. So right here is the solution. So you got step 1, you state the hypothesis. We got no hypothesis is as same as I just said. And alternate hypothesis will be P hat greater than 0.12. And the test statistic, you compute Z. If you're lazy, you don't want to run StatCrunch, you can type in by using calculators and you got the value, okay? And right here you got P hat value. P hat is 0.25 minus 0.12 divided by SE. SE will be the square root of 0.12 times 0.88. If you take 1 minus that, I believe it's 0.88. Divided by 500, you square root, you got the value is 8.95. 8.95 is a huge number, right? So because when you look back the chapter 6 or chapter 6 or I think chapter 6, you find probability under the normal curve. The maximum for the Z, for positive Z to the right side should be about 3.49, right? So if beyond that, like further, bigger than 3.49, the value to the right side will be what value? What do you think? And the opposite is a negative, huge negative 3, less than negative 3.49. So you will get what value? And remember, for if you're doing like this, you got two-way again. You got two-way. You look at the Z table that I provided. Second, you run StatQuant. They give it to you. So right here, let me see what they said right here. The observed value of the test statistic is 8.95 to the right side, right? So this means that what the null hypothesis claimed a proportion of 0.12, the observed proportion was much higher, negative 8.95 standard errors, higher than what the null hypothesis claimed. So this telling you that this 8.95, the value is too large than expected. And right here, let me see. So I run StatQuant. I think I will finish this first, then I will run StatQuant, okay? I will run StatQuant for this data. And right here, they do the next step. They find a p-value. The null hypothesis tells us what to expect when we look at our data. If we see something unexpected, that is when we are surprised, then we should doubt the null hypothesis. If we are really surprised, we should reject it altogether. And right here, they give you also a hint. It's too many writing, but on the test, you don't have to write this much. You only write one sentence, and I will show you. I think there will be more example later for you to see the right format. So right here, they look like they explain really in details a lot, which is my personally do not want you to write this too much. You only write, straightforward for me. And here, the p-value gives us a way to numerical measure our surprise. It's report that the probability, if the null hypothesis is true, our test statistic will have a value as extreme as or more extreme than the value we actually observe. The small p-value, which is we close to 0, means we are really surprised. And large p-value, or another word, close to 1, which is 100%, right? So mean we are not surprised at all. Again, right here, they explain p-value and the significant level. So if we get a p-value that is less than our significant level, our p-value is considered small. We are really surprised and we reject the null hypothesis. This another word, when you find a p-value by the z-table or by StatQuant, you will see the p-value, if the p-value is smaller than 5% formed in the prom, or 1% in the prom, or 10%, then you will reject the null hypothesis. You will say p-value is smaller than alpha, and alpha is 1% or 5%, then you say you reject that. And the opposite, if p-value is greater than alpha or equal to, okay, then you don't reject the null hypothesis. So here is, I'm glad that they run StatQuant here for you already. So right here they have the result. When I run StatQuant, using StatQuant, we can calculate the probability of getting a test statistic at least extreme 8.95%. So look like right here. So when they compute, see that? So in the StatQuant, you will enter this data. Right here we have P of X is greater or equal to 8.95. You compute that, and they give you the probability is 0. It means you don't shade any area right here because the probability here is 0. So 0 is like the minimum, right? Like the very small. It means compared to any alpha level of significance, even 1% or 5%, 0 is still smaller than that. So what do we conclude? We would say this p-value gives us strong evidence to reject the null hypothesis. So we reject the null hypothesis. It means we don't like we don't agree with the null hypothesis. What does it mean? This means we accept the alternate hypothesis, okay? So we conclude for this case that the percentage of Americans who identify themselves as cool skeptics has increased in 2001. So that's the end of 8.1. And I would like to run StatQuant for you to see so that you can run by yourself when you're using this.